Okay, so just a couple more things to wrap up what I need to talk about in lesson 2. Basically what we need to talk about is, I mentioned last time that when you use the new operator, or when you use dynamic memory, so you're creating variables on the heap, the programmer is completely responsible for allocating and then deallocating those variables. Okay, so if I never deallocate that space, and when I say deallocate, I mean return it back to memory so that it can be used for something else. Okay, if I never do that, then eventually my program could run out of memory or start running slowly because it's taking the computer longer to find available memory. Okay, this is a kind of a tricky one when you're writing your programs, because the stuff we're doing in here, you'll never know by running your program. You can't tell whether you're doing this correctly or not, right? You just have to know how to do it and make sure that you're getting it right in your code. It doesn't break your program if you get it wrong. So this is something that you're going to have to be really careful about. And basically, so the operator that we use to delete to deallocate the memory is the delete operator. So we would just say delete int pointer. I don't know why this isn't indented. Okay, so this statement right here, delete int pointer. You have to be a little bit careful when you're reading that. It doesn't actually mean that you're deleting int pointer itself. It means that you are deleting whatever int pointer is pointing at. Okay, so when I say delete int pointer, what that does is this variable over here with the 392 in it goes away. Okay?
Goes away or set to null?
Goes away. So int pointer becomes an uninitialized pointer. Okay? And then for namester, it's the same thing, except because that's an array that we've allocated over there, we put square brackets in between, and that means don't just delete one memory location, delete the whole array. Okay? And so what that means is whatever namester is pointing at, deallocate that so that it's now available for some other use. Okay? Any questions about that? Yeah.
So just to be clear, on the array that'll essentially set all of the values to null inside the array?
No, basically what it does, it's actually not going to change any of those values. It's just going to make it so that the computer keeps track of what memory is available and what memory is not. It's just going to mark this memory as available now. Okay, so
I mean, is it like an uninitialized array at that point, or is the array gone? Like, do I have to redeclare?
It's an uninitialized pointer at that point. Let me put it, so the behavior, if you try to access that memory at this point, is undefined.
But I can store values in there without having to.
Well, no, namester is an uninitialized pointer now, right? So you can't do anything with namester unless you use new again first on it, right?
It's expected that if you have the data in there and destroyed it or
deallocated it,
or then reallocated it back that same, that your data would probably still be there.
It's possible, but you can't. Yeah, no guarantee. Yeah. Okay. Yeah.
Just wanted to make sure I get this right. So when you say, okay, so you set up the pointer with names, star in pointer,
When you say end pointer equals new ints, you're just setting up. Like you're just setting up to make it open to accept the phrase.
Okay, so before I said int pointer gets new int, this over here wasn't here. I just had this variable int pointer. So the int pointer gets new int, creates, the new int part creates this memory location over here, and setting it equal to namester make this to int pointer makes the arrow point to it. Okay?
All right, thank you.
All right. So basically, when you're writing, we're going to be doing a lot with new and delete. So, you know, this isn't the only time you'll see it, and I'm not expecting to be able to go use it right now. Basically, what you should keep in mind is every time you use the new operator, you should be thinking about, okay, when am I going to have a matching delete operator to deallocate this memory that I just allocated? Right, so just keep an eye on that.
Would that normally be done in the deconstructor, or?
It often's done in a destructor, but not necessarily. Right? If it's, yeah, not necessarily. Sometimes. Okay, so there's a section in the lesson on memory leaks, which means sometimes, for example, right now, if I were to say int pointer, actually before I delete it, if I were to say int pointer gets namester. I can't do that because it's a different kind of pointer. Int pointer gets null, okay? Or better yet, int pointer gets new int. Okay? What did I just do? I just created another new variable over here somewhere. And I said, okay, make int pointer point at it. So erase that. And now int pointer is going to point at this thing. Okay. Now, what's the deal with this memory location right here? It's abandoned. That's a good way of putting it. It's inaccessible, right? I have no way of getting to it, but it's sitting there using up memory. Okay, so that's called a memory leak, and it's a situation that you want to avoid, right? Anytime I'm going to, what I should have done is before I did this, I should have deleted int pointer, right? Okay. There's a little more detail about that in the lesson. I'm going to go ahead and move on from it. So now, of course, I need to take a timeout just for a minute here and get some stuff set up because we're changing gears completely. We're starting on lesson 3. I'm still going to need paint. Colors. How do I do? Okay, so I want solid color, white. Oops. No, that didn't work. All right, so I should just do a new. Okay. Paint went away. All right, so here now is when you, if you're watching this as a recording, you're at an advantage because you can fast forward through all of this setup stuff. I have a little program that I want to, actually, you know what? I'm going to stop recording just for a second here. Okay. How come it didn't say recording started? Yeah, okay. All right, so I think I'm ready to go now. All right, so basically what I need to talk about now is what happens when a data member of a class is a pointer, okay? And believe it or not, this is a huge topic, right? We're going to be talking about this for a while because it's a big deal. It happens a lot, okay? There's a lot of times when you're going to want objects that have pointers in them, and there are some issues that arise that we're going to have to take care of, okay? So the way I'm going to talk about it is I'm going to just sort of set up an example situation and sort of an extended example that we're going to be using for a while. And so the first thing we're going to do here is just kind of introduce you to that example. So try to get this, because if you miss this part, then you're going to be lost for a while. So here I have, I'm going to create a class called inventory item, inv item for short. And basically it's going to represent, like for example, if you have a hardware store, each inventory item object represents one type of item. So for example, one object of this class could be 17 hammers to represent the fact that in your hardware store you have 17 hammers. That makes sense? So if you were going to keep an inventory of everything in the store, you'd have to have an array of these objects. That makes sense? Okay. So looking at a little client program just to get us started, I'm going to declare a couple of inventory items. You can see that I'm going to have the insertion operator overloaded so that I can print them out. I'm going to have a set info function so that I can set an inventory item object to whatever I want. I'm going to have a set units function so that I can just set the number of units without changing the name of the description of the item. And that's about it for now. Okay? So this really isn't a lot going on here, just enough to get us started, and then I'm going to start adding stuff to it. Okay? And then here's the output that I'm expecting this main function to produce. Okay, so take a minute and look at that and make sure it makes sense. I just declared item 1, so it's going to say item 1 is 0, nothing, right? 0, empty string. Everyone see where this came from? No questions? Okay. And then inventory item 2, I'm initializing the description, but I'm not doing anything with the units, so it's going to default to 0. So item 2, when I print it out, is going to be item 2 is 0 hammer. Okay. And then for item 1, I set the info to 5 screwdrivers. So here it's item 1 is 5 screwdriver. And then item 2, I'm just setting the number of units to 9. It was already hammer, so it's going to say item 2 is 9 hammer. Any questions about that? All right. So I've set up what we're looking for here. Here, yeah, go ahead.
Why is if you're in the I guess you have to do it the second time, so it takes the 9 units, which is an item 2.
Yes. Okay. So here's my class declaration. You can see I've got 2 constructors, and then I've got the set info and the set units and the insertion operator. Okay. I'm just going to go ahead and start working on those. So the private data member here, this shouldn't be a surprise to anybody, right? That's just an int, number of units. This part is similar to what I was showing you just a minute ago where I had the name stir, right? This is going to be a C string, which is the old-fashioned way of representing strings in C and in C++ in the old days. So this is a pointer. It's going to be a pointer to an array of characters that ends somewhere in the array of characters. There's going to be a \0, so I know where the C string ends. That's the definition of a C string, right? So I'm a little. C strings are one of those things where I'm never quite sure how much you talk about them in your introductory class. So help me out here if I need to say more about them. And I think I already talked about them a little bit, right, last time? So basically, I'll just start from scratch. C string is a way to represent a string in C++. It's just an array of characters. The only difference between a C string and just a simple array of characters is that somewhere in that array you have to have a \0, and that represents that tells us where the end of the string is. Okay? With C strings you can, I can just say C out the C string, and the insertion operator is overloaded so that I can it'll print out the C string. And the way it does that is it just prints all the characters in the array until it gets to the null character, the \0 character. Question?
Yes. Are all C strings stored on the heap or no?
Are all C strings stored on the heap? Not necessarily. You could have just declare an array, an old-fashioned array like you learned about in your previous class, and use that as a C string just as well. Okay? But this is a lot more typical to see it as a out pointer. Okay? So the other thing I will tell you, and we're going to be seeing a lot of this, is that there's a lot of functions that C++ provides that operate on C strings. There's a stir copy function to copy C strings. There's a stir compare function to compare C strings. There's a stir cat function to concatenate C strings, and there's a few others that you'll see. Okay? As we go along. And I guess one more thing I would say about C strings is that they're known as very dangerous things to use. You have to be extremely careful as a programmer when you use them, because if you don't do things just right, there's no safety net. Like, there's no checking to make sure you're doing things right. C++ just lets you do it, and if your program explodes, it explodes. Okay, so you're just going to have to be really careful when you use these things to get everything right. Okay, so let's start writing our member functions. So I'll start with the first constructor. Oh, that's funny. Let's actually start with the constructor that has a parameter. Imb item, imb item. Okay. Help me out here. What do you suppose I should say here? First, the easy part. What's the easy part?
Units equals 0.
Units get 0. Okay. That's correct. So for the second part, if you haven't worked with C strings before, I guess you won't know how to answer this. So sort of like intuitively what we want to say is description gets in description, right? But conceptually, that's what we want to say. But we can't use the assignment operator with C strings, okay? Because they're just pointers. So if I do this, all I'm doing is I'm making them point at the same thing. I don't want that, right? I want two completely separate strings. One called in description and one called description. So C++ provides this function. Oops. Stir copy description in description. Okay, and that is basically the equivalent of an assignment operator for C strings. Okay, it just says copy the in description string into the description string. All right, so this still isn't right though, okay? And this is the critical part to understand. What is description at this point? It's a pointer, and what's it pointing at? It's uninitialized, right? So if I try to do this right now, I'm probably going to get, my program's probably going to crash. It's probably going to say something like unhandled exception or something like that. Because I'm trying to do something to an uninitialized pointer. Okay? So what I need to do is first initialize it. Okay. Now what am I going to put in the square brackets?
Well, you want enough characters so you can handle any word, right? Because I remember for the last one you said it's 6 characters, even though last was only 4. So you want something big enough that it could handle whatever you kind of describe.
Okay, so we want something big enough so that it could handle any string. Unfortunately, that's not possible, right? Because there's no limit to how long a string could be.
I just mean for the particular program we're doing. So it's like, I mean, Screwdriver already has 10 characters.
So you just mean for the particular program we're working on, but for the particular program we're working on, there's no limit to how long a string could be. Okay? So, any ideas what we want there? Even if you don't know how to do it, just kind of conceptually, what do we want there? Yeah? Sorry, behind you.
Well, if you notice, I think I've index isn't it really problematic?
Well, no, that's an interesting question. All stir copy does is it copies the in description array into the description array, regardless, but we have to make sure that the description array is big enough to hold it. Okay? So let me draw a picture. I'm glad you asked that because I probably should have drawn a picture already. So what we have here is, it does not look good on the, oh there we go, just took it a minute. So what we have is we've got description.
Do a length of?
That's basically the idea, yeah. So we've got description here. And so over here is here's my heap. Oops. Okay. And right now this is an uninitialized. That's weird. Okay, so we also have this variable in description. That was my parameter, right? It's also disconnected from the session. So I don't know if that's the broadcast.